Okay, good morning, everybody, or depending on where you are, good day. It's Saturday, and this is T-Formula going live across the world to deliver Saturday morning tonic. I suppose that's a matter of opinion. And today, there are 68 days to go until that GCSE examination in the United Kingdom. We have a session today on equations. That's substitution, expanding, factorising. As you can see, solving linear equations, iterative method, simultaneous equations, only sticking with linear, and rearranging formula. Formulae is the plural. Don't forget to join the Patreon team over at patreon.com/tformula, where you can get these questions a week in advance. Hang around after the live stream today, and for about half hour, I will upload the next week's questions, so you can get onto those, and then you can come along whenever it's convenient to you to either find the answers or ask questions live. That's up to you. Whatever's working for you, you carry on. And if you want to give me some feedback, anything you want to see, please feel free to do that in the comments underneath the video. For now, let's get started. Okay, so these questions come up time and time again. I'm going to say this just once, that there are some basic skills that you require for GCSE that will be really useful going into A-level, and this is one of them. So check out a video that I have on this actually. It's Are You Ready for A-level? But funnily, all of those A-level ready skills are exactly what you're going to need to really crisp up your GCSE performance. So take them seriously, and if you want more of that sort of stuff, let me know. Evaluate H, capital H, where H is equal to this monster. So this is substitution of negative numbers. Again, I'm not going to skip any corners here. I'm going to try and do it as thoroughly as I can. To be said, it will try to avoid common mistakes. And common mistakes here come around forgetting the order in which things need to be done, but also negative numbers. All right, so we have, wherever we have like a letter that is going to be replaced, we'll put a bracket. And then in this goes. What does that mean? What does it do for us? Yeah, there's a bit of delay on the screen today, so I'm going to have to write a bit slower. So what does that do for us? It allows us to compartmentalize the operations to ensure proper boundaries and order of which things are going to happen. So just be careful there. Anything squared, so remembering that this is the classic trick, isn't it? If you put this in a calculator, there's a big difference between it squaring a -3 or doing 3 squared first and then making it negative. The one on the left will give you a +9, and here it's going to be 9 and it's going to make it negative. So there's a big difference. I think that's it. Anyway, this one's a nice easy one to warm up with. Just don't lose your head in the exam, because it's easy to overestimate our ability in stressful situations. Now, this rule of plus minus does apply because it's right next to it. See, there's a bit of a strange screen delay going on today. What could one do? What happens when I do this? That menu come up? No, that's pretty good. Okay, so I can actually access the menu of my tablet, and you can't see that, which is awesome. What I'm looking for, I was thinking what might help was to turn power saving off, but it is off. It must be a wireless network thing. Anyway, let's carry on. 9 plus 4 is 13. It's every time I do a 3, it doesn't like a 3. Very slow on the 3s. And 4 to take with 3 is 1. So our final answer is 13. There we go. Expand. Let me get the mouse down because that's how I move. Can't move with the mouse. Without the mouse, sorry. So expanding the brackets, you have a couple of options here. Like if you're really advanced, you do it in your head. If you've just got a few stabilizers, you'll draw these lines. But if you want to be extra careful, you're going to write this as a multiplication. So every multiplication that you ever do, essentially, you could see it as multiplying to find the area of a rectangle. In just this case, you've got one side is 3x squared, and then you've got the other side, which is made up of two parts. The one, like the whole length, is 4x, and we're going to add x squared, whatever those two are, because it's dependent on where x is. And then we compartmentalize in, just like we did with these arrows, just above the expansion there. It's the same thing. You've got two things to do, but it makes it a little bit clearer, I think. 12x cubed, and then 3x to the 4. And because you're finding the area, you add these two things together. So 12x cubed plus 3x to the 4. Okay, and that's the expansion of those two. Next one, simplifying. Always look and see if anyone has anything written in chat, but not even people. So no worries. The show will go on. So we've got the simplification here. What does this mean? Well, it's factorized is often seen as simplified, but in this case, it's highly likely that we have some b squareds over here and definitely some more over here. So simplified, although factorized form is, it actually means make sure that there's only one of every type of algebraic term. So I need to get all those b squareds together, and that's going to be fully done. So first thing to do is expand these brackets using the method previous or otherwise. So we get 4b times 3b is 12b squared. And we've got 4b times b squared is 4b cubed. You'll have to, every so often it seems to mess up with the writing. And you'll have to excuse me, but I'll try and redo it where possible. Be careful here with the expansion because it's negative. Like what you need to be looking for here is either to treat this as a takeaway, therefore we're going to expand this where 5b squared is a positive, or what most people tend to do is treat this as a negative 5b squared, and then the result of these two multiplications just get put right next to each other. And I'll do it that way. I just prefer it that way. Might save some time because if we treat it as separate, we've then got to apply the negative across the bracket. So negative times positive overall is negative, and we've got 20 with the 5 times 4 b squared, and then we've got negative times negative, so it's a positive 5 times 3 b squared times b. Lovely. So now we can see we've got some terms that are in the same, I like to say in the same family. These are the b cubeds, and I'm going to be careful to highlight the sign next to it on the left. Really important what we do with that. And everybody meet the b squareds. It's two families there, and we're going to add them together in their family. So we're going to do the positive one first because we usually leave that at the front. I could tell that the greens are going to be positive, so I have 19 of those b cubes, and I know this other one's going to be negative, so that's going to go second. Yeah, a bit of a delay, sorry about that. That's better. Okay, so this is simplified down so that we have all of the b cubes and b squareds together. And if I'm being super technical, we can take a b squared out of this. Not 19 is a prime number, so let's do this. 19b subtract 8. Now, this factorized form is fully simplified, but the exam would probably, be happy with this. But factorized form is simplified form. It allows us to cancel any factors possible, but it's seen as a more simple form. You can really see it for what it is. It splits a bigger expression into factors, more easy to use. Okay, so let's see the last one. Now, a lot of these are going one way. This is going backwards. This is having something that you need to add brackets to and call it an area, and you're trying to find the two numbers that multiply together to get this. Well, let's have a look. I just had a look at my streaming software. Just check. I guess that's for if it's recording, that's streaming, but I just thought it'd be recording at the same time. Maybe that's just YouTube. Never mind. Onwards. What we notice first of all here is that, in fact, hidden in this expression is the same two letters, just sort of the wrong way around. So this essentially is JH. So if all letters are multiplying together, they may look like they're different terms, but they might be written in the wrong order. So this is preferable to look at it this way, just in case we've got some JHs there. It looks like there's a J and an H in every single one, and it looks like 8, 2, and 4 have a common factor of 2. So first of all, let's look at all the numbers that they have in common. It looks like we can divide 8, 2, and 4 by 2. Nothing bigger. If we went for 4, it's too big for 2. There's a J in each. Is there a J squared in each? No. So we have to go for the smallest term that's in all. And again, for H, there's only one H that goes into all. I know we've got an H squared at the front, but there's not an H squared in the other ones, so it's not in common. Now, there's a really good way of doing the factorizing. It could be quite overwhelming to think in your head right now. Oh, so if I took that out, how would I get to 8JH? Okay, there's two ways of doing it. If you know what you're doing here, and you think, well, it's 2 times 4 to get back to the 8. I've already got a J, and I just need another H, then that's fine. If you want to do it more methodically, because it's very difficult, the act of taking this out can be seen as a division, because its opposite, where we were to expand, is actually a multiplication. So we could see at the side 8JH squared divided by what we took out, which is 2JH. You can cancel down as appropriate. So 8 divided by 2 is going to leave with 4. And then the J's are going to cancel. And H squared at the top is going to cancel 1H down there. So as you could see, like we found before, we're left with 4H. Like, that's a really long way of doing it, but hopefully not always needed. Plus 1, 2JH divided by 2JH is 1. That's like a confirmation, if anything else. And then divided here, so we've got 2. We need another J. H is sorted. Don't know about this delay, but I'm not going to stop the live stream. It's just a little bit unfortunate that the delay is there, and I might need to rewrite a few things. I think that's it for this page of the basics. Yep, I don't think there's anything else. So congratulations if you got some of those correct. If you have any questions, don't be shy, ask away. You may have noticed these are fairly complicated questions on the whole. They represent a decent challenge to roughly what the GCSE will be. It's extremely encouraging if you can do these. It will definitely indicate you're quite ready. Okay, so the next stage would be to look at a few different varieties of solving equations, only in the linear sense, of course, and look at some strategies. Your first instinct here might be to expand the brackets, and you would be forgiven, and you're actually not wrong. You can't go wrong as long as you do the same thing to both sides. It's like very simple, actually, when you're doing these solving equations. Just do the same thing to both sides with an aim to get the unknown on its own. That's as simple as it is. And you could say, oh, do this first, do that first. As long as you do the same to both sides, you are not going to violate the relationship, like the equal sign. It's still going to remain balanced. But what you will find is that over time, you probably take longer doing certain things before others. And that's fine. That will, come with practice. But at least you're safe in the principle that if you do the same thing to both sides, you can't go wrong. Now let's explore two options here. Let's expand with this 8 first. So that would become 40m plus 64 equals 24. And then, well, what would you do next? You probably take away the 64 from both sides. So it's negative 40. And then divide both sides by 40 to get negative 1. And we'll double check that works just quickly. Minus 5 plus 8 is 3. 3 times 8 is 24. Perfect. The other way that you might explore over time, if you do the same thing to both sides, because it's 8 times this whole bracket, which we could just call one thing, a factor, we could divide by 8 to begin with. So we get 5m plus 8 equals 3. You compare this with this. We got rid of the bracket, the bigger numbers, right? So I guess there's a whole skill here that we're expanding. And the bigger numbers now make it slightly harder, I suppose, but it's fairly on par. We've got 5m. I did recently a video on this, a really decent sized video, and trying to think what it's called now. Let me just get that up. I think I could flash it on screen if I'm really good. Where is it? This one. Yeah, there it is. All right, let's come down here with this. I've got 3 screens, so let's take it to the right screen. It's literally that one right there. Okay, you see where the H is on the bottom? All right, you might be able to do that question, fine. But this went through solving linear equations pretty well. And it goes through about 8 different ways of solving that particular equation and shows which is most efficient. And over time, those basic methods become tricks as well. So you get even quicker. But it's a pretty good video to look through all the different, what happens if, say, here, you decide instead to divide everything by 5. Many people do decide to tackle the 5 first, vicious bunch of people, but it's not necessarily wrong. The only thing that they forget to do is divide everything by 5. So take a look at that video and see what you think. Hopefully it's useful. If not, well, call yourself a master of the equations. Now we've got negative 5, and then m equals minus 1. Somehow we've done it in less steps. I suppose we would have, because essentially this was there, right? So we've only gone down 1, but 3 steps, and it's just smaller numbers. You choose what you want to do. Solve for x, another problem. People, this is literally, I've seen an exam question like this. This isn't here for no reason. It's because this is very much modeled on something you'll see in the exam that still people get seriously wrong. All I can say is the main problem is you try and deal with the numerator. Like my biggest thing, if you know me, is to get rid of the denominator. Okay, so get rid of the fraction. So times by 8 first. So we're left with 5x plus 3 equals 16. wonder what it looks like on the replay because it's really slow writing on this screen. Should have reset, but c'est la vie, mon ami. Take away 3, and then we're going to divide. Uh-oh, this is the stage where we think, have we gone wrong? There we go, I just need to rewrite that because illegible. Have we gone wrong at this stage? Not necessarily. It's a really good moment to mention the meme. You put this on the calculator and what comes back is literally 13/5. Well, you press the S to D button and you get that it's 2.6. But I'll be honest with you, this, all right, here, this is the best. The fraction is the best answer. In my opinion. Yeah, it's pretty neat. All right, find a value of y and x. Probably not what you think. What's your first instinct here? You're going to grab the bull by the horn and say, let's multiply this by this. Yeah, no, don't do that. What you're going to end up doing there is creating some crazy nonlinear equation between x and y that's not going to be very easily solvable. But let's use our brain for a second. This is a rectangle where opposite sides are equal. So just taking a look, 8y minus. So we're actually looking at a really important skill. And we'll take the time to write it, as painful as it is. Equating. So we're going to put what is equal. Rearranging these equations, like solving them like we just learnt. And we get y equals 2. And the same down here. 20x subtract 2 equals 28. So 20x, I'm going to add 2 to both sides, becomes 30. And then we're going to get rid of that 20, divide by 20. Eek. I do get a bit annoyed seeing x's that don't connect together, but you have to forgive this pen today. Now 30 divided by 20, we could just skip straight to 3/2, which is 1.5. And we were asked to find the value of x and y, and we've done it. I normally put brackets or boxes around these answers, but I don't know if I want to tempt fate with the screen today. Just hopefully get through things. All right. So show that this is a type of question that comes from iteration. Oh dear. Anomaly on the screen. Well, let's hope it sorts itself out later. Don't think you could see it, so that's really good. Show that the equation 2x cubed plus x equals 5 has a solution between 1 and 2. Well, in very simple terms, equations, if you plot them, look like this. Just as one, there's many. And where it crosses the axes is called a root. And the root is the solution to the equation, which geometrically is where it crosses the x-axis. This is where y equals 0. A few clicks happened there in people's mind. But we're looking for this point, meaning that if we put, let's say the solution was in between 1 and 2. So let's draw it like accurately, really something like this. So there is the number 1. And there is the number 2. So essentially, if we put 1 in, the output will be down here and negative. And if we put 2 in, the output will be up here and positive. So we're looking to see a sign change. That's the premise. Okay, so the first thing we can put in is when x equals 1. Just be careful on your calculator. So 2 times 1 times 1 times 1, which is 2, and plus 1, which is 3. And essentially, what we want to do to really prove this is sort of rearrange it. So proving that the solution is between those two, in this case, means that it's going to be either less than or more than 5. But if we can put it into a form such as, let's get this around, 2x cubed, I have to go slow, because otherwise this screen's going to mess up. And at the moment, I'm really loving having this screen because it allows me to use a really great writing pen. I might need a graphic card upgrade. Right, 2x cubed plus x minus 4. If that now, I've moved the 5 over, that's now equal to 0, which essentially is my y. And when I set y equal to 0, that's going to be that root that we talked about, where it crosses. If I put it in this form, like this, I'm hoping that the output y is going to be either less than or more than 0. That's the theory. And the reason why I have to have it in that form is because this graph takes an x in and a y out. So I need to have all x on one side, everything that pertains to that relationship to give us a y. Now, if you don't want to do it like by rearranging and then putting it equal to y, so get it equal to 0 and then put it equal to y, you're just going to have to put it into 2x cubed plus x, and the output should be less than 5 and more than 5. So here we've got 1 times 2 is 2, plus 1 is 3. 3 take away 5 is negative 2. And then when we put in number 2, then we get 2 cubed, which is 8, times 2, which is 16. 16 plus 2 is 18. And then take away 5 is 13. So y equals 13. Now you could put like the whole working out. Essentially, you'd like to do something like this. And that shows what you're going to put into a calculator. It shows a substitution. But you can see that there is a sign change. And that's what we're looking at there. Negative 2 goes to 3, so to 13. Therefore, we could say that there's a root betwixt 1 and 2. And do you know what? I'm probably going to say plus the function is continuous, because there is an assumption that this function, I can't even write with this, it says like continuous. There's this assumption that this in between 1 and 2 will be like continuous and not just stop suddenly. A lot of people make assumptions in life, but especially in maths, that patterns they see and graphs go on forever, behaving the way that they do are all numbers. And it just isn't the case. There's so many examples where they just go off the rail at particular values. So we'll assume that it's continuous too. Right, moving down to the next part. So we've done our whole checking that it's definitely between 1 and 2. Renesmee rearranges the equation in 2 different ways to find 2 iteration formulae to help find an estimation for the solution in equation part A. So we all know this method. It's taking the equation up the top and isolating an x. So that could have been straight away moving over the 2x cubed, and then you've got an x on its own. The x on its own becomes xn plus 1, as in the next one in the sequence. And all of the x's on the right-hand side that you moved away become xn, which stands for the current value of x. And we put the current guess, or the start value, in to the xn. And once we do that into here, it outputs an answer, which is the next guess. And then this will go straight back in as the next input. All right, so that's the procedure. The next stage is just like, how do you stay organized with it? But sometimes in the exam, they ask you to rearrange the equation to show this. Should be okay, right? It's a skill we should know. But this is sort of after that. This asks us to look at the following two arrangements. Starting with x naught equals 10. So when it's x naught, that means the initial. And obviously, when we put that in, what comes out is x1. Perform 4 iterations of each to show how one formula is better than the other. You must state your reasons clearly. Okay, we could do this. So essentially, we're going to need a table to stay organized. What is the table? Well, I suppose you could say your current guess of n, and in this case, x naught is our current sort of initial guess. It's a very high number, but whatever. And we'll perform 4 iterations, and an iteration is substitution, so we're going to have to put it into the equation like this, and what's going to come out is xn plus 1. It's kind of a redundant column, but in a sense it keeps that methodology going. So when we put 10 in, 5 take away 2, lots of 10 cubed. Why did I put 100? 10. So that's pretty nasty, actually. I don't know, that's very nice. So 5 times, I would just say that's 1,000. So 2,000. 5 take away 2,000 is minus 1995. Was that a song? I got that wrong. Back to 1990 something. Yeah, it doesn't look very nice. Right, what we do for this next one, so we know now that x1 is negative 1995. We put in our calculator not that number, but instead we use the answer button like this. So we have to type in 5 take away 2 times, open bracket, press the answer button, and then cubed. And then when we press equals, we're going to get our number, which is like 10 times 10 to 10. It's like ridiculously big number. It's 1, I'm going to just write it in standard form, 1.58 times 10 to the power of 10 each. We're going to press it again, and at this point we're going to get x2, and we're going to do it once more after that. So x2 is negative 8 times 10, should we zoom in, to the 30. That might have been a bad idea. Are we back to normal? Click, click. Click. There we go, that'll do. Alright, I'm never doing that again. And then x3, if we press the button once more, you blimmin' heck, 1.02 times 10 to the 93. Okay, so I think you're getting the idea that this number is getting bigger and bigger. What we would call this is divergent. I'm hoping that the other rearrangement is better. For those that want to learn how to spell, you can't be looking at my writing here. There's such a delay on the screen, I'm sorry. Right, so that didn't look like a very pretty picture. Look at the other rearrangement, and sometimes you will find this, that different rearrangements are better. So I'm hoping that that's the case on this question. And if it isn't, never fear. We did the right thing. I hope. Looking at the working out is a way to double check, of course, but let's see. Right, this is the cube root of 5 subtract xn over 2. Okay, let's see if this yields anything better. Move this down. Now we have to start with 10 again. I think if this turns out to be a reasonable number, we have a very good chance of being successful. I saw negative 1995. I thought, yeah, that's not the best. I've seen better. Take away 10, all over 2. Okay, reasonable. So you need to show, I suppose, just at least one of those iterations. And this is what has gone into the calculator. And what's come out is x1, which is the next one after x0. And it's negative 1.35 ... because we don't want to write it all. Now, just take a look at what we're aiming for here. We know from earlier that the solution is between 1 and 2. So that first sort of rearrangement formula being divergent, no good. But if we immediately come in at minus 1.35, I know it's negative, but sometimes these have the effect of getting closer. Sometimes they oscillate, which won't be good either, but they get a bit closer, and at least it's not going as big as 2000. And if you look at them like geometrically, they kind of spiral. So we could have started at 10 over here. It takes us to negative 1, then back up to 3, but then eventually we're going to be between 1 and 2. It's like a spiral. That's what I'm hoping we're going to see. And do you remember what we do after this? We know that x1 is negative 1.3 ... but we keep it in the calculator, and our next bit of wizardry is going to be that lovely old school 3. 5 subtract answer, where's the capital A? There you go. All over 2. So we have to be brave and keep it on the screen, and then press Shift, and choose a cube root, fraction on the top, 5 minus answer button on the bottom 2, and then equals. Lovely. So we didn't discuss this before, but the thing that comes out after putting x1 in is x2. So essentially this is x2, and I think it's very promising, 1.47. But because we have that on our calculator already, in the terms of answer button, to find our next one after this ... is it's just a matter of pressing the equals button again. So press it once more, and I get x3 is 1.208. And just for fun, that's actually 4. It seems to be convergent upon a number here, but just for fun, I'm going to press it again, and I get 1.2376, and again 1.2344, and again 1.2348. And to highlight what's happening, in the first instance, none of them were consistent. We have 1.208, which is inconsistent with the previous one, but then all of a sudden we've got let's choose a different color there, hold on, yellow. We've got 1.2, which is consistent with the previous 1.2, and then the next one along, we've got 1.23, which is consistent previously, and then 1.24. So it seems every time we press the equals button, we lock in another number that doesn't change. And eventually we're going to settle upon the fact that it's 1.23, and we'll just stop there, 2 decimal places. Is 4 iterations enough to show this? Well, we know we can go extra for fun. x3, 4, 5, 6, wait, 4, 5, 6, yeah, 6, 7 is it. So 1.23. So this is essentially how it works. Now 1.23, as you got to that point by a method which feels like trial and improvement, and it kind of is, but essentially you could see this graphically. I'm not going to do that now, and it would be, if you wanted, you can leave a comment on seeing this and how it works. But I've put an animation in my shorts which shows how, if you pick an x naught, based on all the different rearrangements, how it spirals round to get to the solution. But that was done with Manim, actually, which is 3 Blue 1 Brown's Python code. I do plan to do a few more of those, but it's about finding the time, isn't it? So there you can see it visually in my shorts, and thankfully I don't have many shorts on the channel, so it won't be long to find it. But it seems that this one is convergent. So it goes towards a solution, meaning that if we were to solve the equation at the top, right here, for like when it crosses the x-axis, or just generally we call it solving, then it will be 1.23. Okay, moving on. My auntie loves high tea. She was raving about Edinburgh Park. Have you been to Edinburgh Park? Just outside of Wales. Very, very pretty place, where a local harpist, true story, plays softly at the side. She has 6 scones and 3 cups of tea for a table. Okay, that seems like important information. So 6 scones and 3 cups of tea. Mixing numbers with words. Tricky, eh? And this cost $43.50. She gifted me an afternoon there, and our bill came to $88 after having 11 scones and 7 teas. Okay, so we've got 2 bits of information about 2 variables on 2 different locations, and we're assuming that the price stayed the same between the 2 visits. Let M be the cost of a scone and N be the cost of tea. Show the scenario as a pair of simultaneous equations. Oh, beautiful. I love these questions. So most people break down here and think, the more you see of these, the better it's going to be. But it's kind of helpful here to say M is the cost of a scone. So let's talk about the cost of these things. So in the first instance, there were 6 scones. If we knew the cost of a scone, we'd multiply it by 6. And they're telling us that the cost of a scone is M. So we're just like 6 times M. And we're going to add the cost of the tea. There were 3 teas. If we knew how much they cost, it would be 3 times the price of a tea. So we're going to add 3 times the price of a tea, which is N. If we did this and added it together, we would get what we would have to pay. And it says up here that that was $43.50. So this already is an equation because we have an equal sign, and it involves 2 variables. Therefore, we need a second equation to properly solve this situation, and thankfully it's not just the same information. When I went to the afternoon tea, the bill came to $88. So this is different information, therefore we can use it. This time it was 11 scones and 7 teas, and it came to 88. Now both of these represent an equation that if you drew it, I'll just draw it roughly, it's not real. I can't tell you this is exactly it, but it's roughly like this. Let me change color. So the first one might look something like this, and the second one might look something like this. And to give you an idea of what's going on graphically, we're looking for this point here where they cross over. This will be a value of M, if we have an M axis here, which is usually X, but it's M now, and N, which is a value on this axis. Right, so X and Y usually, if you want, that point represents where these two intersect. So that's really what we're focused on. And we could do that. I think it says here, when I went for a second time, this time in summer, I only managed 5 scones but needed 6 teas due to a heat. What did it cost me? Well, we can't very well answer how much it cost if we don't know what M is, which is the cost of a scone, or N, which is the cost of the tea. But these two equations at the top here, if we solve them, will give us the value of the scone and the tea. So we're going to solve them simultaneously to find, and then we can answer how much this new scenario will be. Like, I've got a calculator that does this for me, so why would I go through the ordinary methods of solving it? Well, sometimes you have to, like generalize it. You want to be more in control of the process. So we're going to do it old school today, and we're going to do it with some of each of these. So currently we don't have any in common, so I'm just going to focus on the smallest number, which is the 3, and I'm going to multiply that by 7. So don't go too fast for you, I'm just going to show you what I'm doing. I'm going to make this value the same in both equations so that I can use this process called elimination. That means multiplying the whole of the top equation. You are allowed to do that as long as you do everything by 7. So 6 times 7 is 42, and 3 times 7 is 21, and £43.50 times 7 is 304. The pen, I'm afraid, I'm sorry if I go a bit slower. At least you can watch the replay in twice speed. And the bottom equation, we need to multiply, let's show you the focus is to get 21 there. Therefore, 7 times 3. Everything gets multiplied by 3. And this is the hard bit, times 3, but if you've got a calculator, use that. 240 plus 24 is 264. Right, so those are the two new equations, and if we use our, let me scroll down. We use our logic here, we could say that if we take away the top from the bottom, it's a good way to do it actually, because 42 is bigger than 33. Sometimes it's not always nice like that. Then we end up with 9m. 21, take away 21, that's 0. We just leave that. And 304.5, take away 264, is 40.5. Lovely. So m equals, nobody said this was a very cheap place to go, but we divide it by 9, we get £4.50 for a scone. It's one of those luxurious places. Okay. And now we know what m is, we can put that back into any one of the equations, and I would pick the smaller equations at the top because they're smaller numbers. So 11 times 450 plus 7n equals 88. Yeah, got there eventually. And to skip a few steps, I'm going to do 11 times 450, which is 49.5. I'm going to do 88, take away that answer, and then divide it by 7. So I get my value of a t at 550. So what do you think? Is a t worth 550? Je ne sais pas. It's a thing is what you're willing to pay for it, right? Now we can answer this last bit. 5 scones. So 5, you know what would have been better here? To label it with context. So I can just quickly see and be sure of what I'm doing. All right, 5 times 450 plus 66 times 550. Certainly more expensive if you're thirsty, isn't it? You can see that the effect of having more teas is bigger than having more scones because they're worth more. Right, be careful when you do this calculation, but having a calculator makes life a breeze. And in total, 5520. Do we think that's reasonable? We might want to take a look for reasonability based on previous times. 11 and 7 gave us 88, and 6 and 3 gave us 43, and it's somewhere in between, so I'd say that's fairly reasonable. Love these real-life simultaneous equation questions. I love forming the equations and solving them. It feels really useful, working backwards. And these are very rudimentary situations, but they're super useful when it comes to 3 unknowns in things like engineering and anything that's like business-related process problems. So solving systems of linear equations where technically there could be infinite variables, infinite unknowns, or very lots of them, and many, many equations. Sometimes there's two. This would be a riddle for you if you're interested. Sometimes there's not enough equations to solve. So you say here we've got 2 unknowns for 2 equations. Excuse me, drink. And that's really great. But sometimes you've only got 3 equations to solve 4 unknowns. Sometimes you've got 10 equations to solve 3 unknowns. That's called overdetermined or underdetermined. You see vice versa. But point being that there's a whole world to get onto. They're so useful at the very top end, even used in AI. So what you're looking at right here is the building block, the first step that you can take towards understanding artificial intelligence systems, if that's where you wanted to go. Anyway, looking like ahead 5 to 8 years, let's come back to the present. Last page. Ah, lovely. Looks disgusting. No, joking. I love all questions equally. Yeah, I think except mechanics questions, they can go to the bottom of the pile. But I do get put off by all of these stuff. Let's just see what we could do. This question is excellent for testing skills with BidMath and algebra. Thank you. All right, make X the subject in the equation below. Gosh, what can I say? When we rearrange equations, for some reason, it's one of those skills that people don't like. It comes with confidence, and when you're looking at these questions in terms of solving equations, you're doing the same thing to both sides. You can't go wrong. You can just learn from it. And we've got to be super careful here. But this is much more simple than you'd think. Let's get going with it. So make X a subject in the equation below, leaving your answer in this form. Looks like some weird quadratic to me. But let's see what happens. Like this, I'm not going to worry about this until the end. Just going to do what I can to get X on its own. State the values of A, C, and D, which are integers. Okay, whatever. Don't worry about that. Just don't worry. Just get X on its own. Think about this like this, I would. We could get rid of a chunk of it already by seeing this as 2 fractions, right? So 3x plus 9 over b equals, so we're going to take away that whole fraction from both sides. 4 plus b minus 5 over 4. Right, so we add that to both sides. And then we're going to multiply by b, because you can't tackle the numerator. Excuse me a second. The numerator is actually locked in. Just going to take a drink now. Hold on. Stay hydrated, people. Otherwise, bad things happen. So if we times by b, we've got 3x plus 9 equals 4b. Nice. But I think a lot of people forget that the b multiplies everything. When I say everything, I don't mean the 4 down the bottom there. I just mean like the b would multiply that numerator. And if you expanded that, I've jumped straight to what that would be here. So now it starts to look a little bit like we got some b squareds, like it says up here, but we're not going to get too excited yet. Just going to keep going. Just stay calm, just like when it's 2 days before Christmas or something. And keep our dignity. We're going to take away 9 from both sides. Getting so close now. I'll tell you the longest part of this is writing it out, but it's very good discipline. Everything underneath where it was before. And finally, x equals, we're going to divide by 3 here. So 4 over 3b. And this is a little trick. If you're dividing by 3, put it other side here, divide by 3 is the same as multiplying by its reciprocal. We know that from when we're dividing fractions, and we turn it into a multiply instead. So if I were to divide this by 3, it's like going to turn to 12 on the bottom because it's like 3 times 4. And this becomes 3. Magic. No, and sometimes my magic wand doesn't seem to be working there. Let me go slower. There. So we'll get everything divided by 3, and what it's asking for is to, oh, there's a hint, 12ths on the bottom. What it's asking for is that we get it b squared and b and then a number. So now the focus is on the right-hand side to rearrange this. So it's a big old rearrangement question, this. So we got b squared. So essentially we want to separate out this fraction here, there, to be like the denominator shared between both, right? So we get, let me just take a look at that final form again. Yeah, we'll bring the fraction out the front. So 1/12 b squared minus 5 over 12 b minus 3. Looking good. And we need to get those b squareds together. Now you can see that the b and, oh, anomaly. Let's go back there. You can see that the b here and the b here have to be combined at some point. So we're going to have to do something about this denominator at the front. So to make it in 12ths, we're going to times that by 4, and that's what's going to have to happen to the top as well. And one last row. We're going to get these, sort of raise all together. Put the 12th in the front, essentially. 12b squared. Let's go up and have a look. If you have it on the page, it's easier to keep looking up. But it looks here like a is 1. And the amount of b's, we've got 16 over 12b. And take away 5 of those 12ths. So we're going to be positive in life, but also this is going to be a positive here. And then the negative 3 is just what it is. Right, we've done it. See, I said don't worry about that. Until you start recognizing parts of it, don't worry about it. We got there. So we need to state what each of them are now, right? So it's clear that a, being the numerator there, is 1. B is equal to 11, positive 11. Is it A, B? Let's check. No, it's C, is it? Yeah, it's C because we're using B already. And then D is that last letter on the end. It's 3. And if you were shouting at me there thinking, oh, no, I didn't get that, you're wrong. Yeah, I know. I'm just checking who's paying attention. It's -3, right? Because up here, it's written as plus D. This isn't plus. So if you want to be really technical, you could say plus -3. And you know that's the same thing because plus next to a negative is a negative overall. I think that in these live streams, we might be on a roll to keep taking longer each time. So next time, I'm going to try to be quicker. Maybe less questions. All right. Do we have any questions in chat? No. But you know what? I'm going to put some hundreds in the chat because it's fun. That's been great, everybody. Thank you for showing up. And don't forget, follow the channel. You'll get the notification for next week. And if you go to the Patreon, you will find in about half an hour from now next week's questions, which I forgot what they are. I made them all in advance. If you stay around for about 30 seconds, I'll tell you what they are. I'm just going to open them up. Live stream, set is my tonic, spirit these question sets. Pythagoras. Okay, Pythagoras and trigonometry. It looks like this. Anyway, there it is. Pythagoras and trigonometry. So stick around for a half hour and head on over to Patreon. It's totally free. You don't need to sign up. Just go there, click it, download it, have a go. And we'll get better together. And whilst you're there, if you want, put a question. If you don't want to do this, then say what you want to do. And there's also an opportunity to change the order in which we do the live streams. If you go to, let me see, I'll leave it in the description of this live stream, but there'll be a link to the, what was it I was going to say now? The schedule. So a link to the schedule that you can see like what's coming up, and if you disagree with it, as we've probably realized, there's maybe 8 more sessions after the pre-scheduled ones. You're not going to get through them all, so we're going to be working through in order, and maybe the final 8 live streams will happen after the GCSE. Sorry about that, but that's just the time of life that it is. So if you want some of the later ones to come forward, it doesn't matter, we can do that. Just love to hear from you and what you need. That's all it's all about. So signing off for this week. It's good to have you around, and goodbye.